Hello, my name is Jacob Roginski. Welcome to my term project. Surface Sweeper is essentially Minesweeper, but played on the exterior of a cube. From the main menu, you have two options. You can either go to the directions screen, which shows some basic gameplay instructions, as well as how to control and navigate the cube once you're in the game. And then you can click Play Game, which takes you to a game customization screen where the user has to choose the cube dimension as well as the total mine count, which is the total amount of mines that are across all six faces of the cube. Playing game brings you to the gameplay screen, where you're given a cube. You can manipulate it by turning it in any direction and zooming in or zooming out. You reveal any square by clicking with your mouse, and you can mark and flag mines by pressing the spacebar when hovering over a particular square. Now, if you have a total of 8 mines, it never lets you place more than 8, more than whatever total you have, and you can mark and unmark mines as many times as you want, indicated by mines left over here. In addition, you can press New Game to start a new random game given your specifications. You can go back to the menu at any point in time, and you can also reveal mines, which ends the game instantly. Now, every time you click New Game, what's going on here? Well, it's creating an object that contains a dictionary with all the values of your Minesweeper game, given the dimension you chose and the total amount of mines you chose. And it does this using a stars and bars technique, placing the total mines across the six faces randomly, while also ensuring that every face gets at least one mine. At the same time, it creates a blank dictionary of the same size, which shows all the values that are displayed, which in this case it's blank because when you start the game, no values are displayed. At the same time, we've got 8 vectors being created, one for each corner of the cube. And these vectors are the ones that undergo a linear transformation every time the cube is rotated in any direction or scale to zoom in and out. Furthermore, the user doesn't have to see the entire cube. They really only need to see half the cube at any given time. So there's a function that identifies which 3 faces at most have the lowest aggregate z value and then chooses to display only those on a flat projection. There are also helper functions that draw some of the auxiliary features of the cube, like the nice grid lines we see, which change based on the dimension, as well as ensuring that any revealed square is placed exactly into the center of the square it's in, and then also the feature that highlights whatever square your mouse is hovering over. This highlighting part uses barycentric coordinates to identify whether or not an XY point is within a parallelogram, given the corners of that parallelogram. Now, as the user reveals mines, it copies the values from the board dictionary over to the display dictionary, one at a time. And the trickiest part of this is whenever the user clicks a 0, it needs to flood fill, oftentimes over different edges, in order to expand the area and then cover the perimeter. And it does this using a recursive function that checks whether or not a square is adjacent, whether or not any adjacent square is also a 0. And if a 0 is adjacent to a 0, it's got to reveal both, so on and so forth, all the way until all zeros within that fabric are showing. So there's a roadmap that it accesses, which has information on how to iterate through adjacent faces, using a different technique for corners and a different technique for edges and a different technique for central pieces. And lastly, we need to be able to check whether the game has been won or lost at any given point in time. It's easy to check if the game is lost because that happens whenever a mine is revealed. We get the game over screen. And in order to check for a win, there are 2 ways to do this. One can either check every single square on the cube and check whether or not it's been revealed, but that's foolish. That's very inefficient. So instead, what it does is it checks whether or not every square has been revealed on a given face. In this case, no, we've still got an unrevealed square. And as soon as it finds such a square, it stops checking. It knows the game hasn't been won yet. However, now, as soon as we place that mine, every single square on this face has been revealed. So it discards this face because it doesn't need to check it anymore. Next time it checks whether or not a game has been won, it does this on a different face. So at most, at any given point in time, you're only checking a maximum of 1 face. Now, to see whether the game has been won, it's very easy given that we chose 6 mines for a 10 by 10 grid, and as a result, we have the win screen as desired. That's the game.